right, this video right here is our doubling in time in Half-Life Stations. And normally while we're in school, we go around the room and we practice this. There are 7 stations total. So I'm going to kind of go through step by step how we practice these. And I'm going to let you know, anytime I use doubling in Half-Life Stations, I always use the formula y equals ae to the kt. So I'm always using the continuous formula. Now, if I say it, great. If I don't, you can still use it as well, because usually when you see doubling time in Half-Life, you are going to use the continuous exponential equation. Okay, so here's our first one. It says a population doubles every 15 years. So if it's doubling, I know that it's increasing, so my k is going to be positive. And I know my time, it takes 15 years for a population to double. I don't know what I started with, but it doesn't matter. What is your continuous growth rate? So this is what we're going to do. You're going to do y equals ae to the kt, because you have to come up with your formula. And then we're basically trying to solve for the continuous growth rate. I don't know what k is. I just know it should be positive. But the easy one to plug in is the 15, because the 15 is going to go in for time. And if it doubles, if I start out with a, I know it has to go to twice of whatever a was. And I'm going to plug the 15 in here and just switch their spots. So I'm basically solving for k. This is like one of the easiest ever equations to solve, because if I start dividing out to solve for k, I can see my a's cancel, so I can say thanks for playing. So I know that E2 equals e to the 15k. Because k is up high, I can natural log both sides to solve for it. Thanks for playing. That's the beauty of using your continuous exponential function. When you natural log it, it undoes it. So I have the natural log of 2 equals 15k. So k equals a natural log of 2 over 15. And when I put this on my calculator, and at least go 4 decimal places, you can go more if you want. So it's 0.04621. So if I move it 2 decimal places to the right, this is going 4.62% growth, and it's continuous growth. So that's what this is doing. It doubles every 15 years, so it's going, its growth is 4.62% per year, if you will, growth. And that's how you would do that one. All right, so that's station 1. Station 2 is kind of fun as well. Station 2 says carbon-14 decays, so I know it's going down, right? Decays radioactively at a constant rate. So they told me my rate, but the one thing I got to be careful, if it's decaying, my k has to be negative. So when I put this finally in my formula, I got to make sure that I make it negative. That's a common mistake. It says show that the half-life is 5,728 years. So basically, they gave me the answer is 5,728 years. And I'm thinking, wow, that's long for half-life, but not really. Look how small this percentage is. If I move this to the right, well, excuse me, this is already a percent. So it's 0.01%. So it's it's very small. So if I'm going to, the other thing you got to be careful, is there a percent here? I misspoke myself. You're not going to go to the right. You're going to go to the left to make that a decimal, because you have to divide it by 100 because the percent's there. So let's set up our equation. I have y equals ae to the kt. So basically I'm going to be solving for t, and hopefully I get 5,728 years. So they said the half-life, and they told us the rate. So this k is going to go here, but I got to make sure that I move it 2 places to the left. So I'm going to have actually 3 zeros. So I'm going to do, okay, a half of a is left, and they told us the rate is negative 0.000121. Wow, that's small, and I have to put the t there. So I'm solving for t. Now I'm going to divide both sides by a, so I can say thanks for playing. So I have a half equals e to the negative 0.000121t. Then I natural log both sides to solve for that. Thanks for playing. So now I have the natural log of a half equals negative 0.000121t. Then I'm going to divide by that. So I have t is the natural log of 1/2 divided by negative 0.000121. And when I do that, I actually get 5,728.49, which is 5,728 years, I actually proved it. And on a normal instance, I'm like, oh my gosh, that's so big. Am I sure I'm right? But it does decay. Look at my K. It is so small that it will take a lot longer. All right. The other thing I look at is when I was telling everybody in class is a lot of times when they do paintings and they're checking to see if paintings are authentic, they actually test the paint to see if because they know the chemicals in the paint and how they decay, they can tell um, if it's a Picasso or any of those that it was done during that time period, that it's not a fake. So that's kind of interesting. It's called carbon dating. All right, station 3. A substance decays continuously. So I know this is negative K. The half-life is 11 minutes. Wow, this one's fast. This one takes 11 minutes for half of it to go away. Maybe it's a gas. How much does it decay per minute? So they basically want us to solve for K. I want to know per minute because I know it takes half of it to go away in 11 minutes, but I have to figure that out. So, ready? Y equals A e to the KT. Plug in what they told you. 11 minutes goes here. They said a half of it, of my A, goes away in 11 minutes. I just switched the two spots. Divide out the A's. A half equals e to the 11k. These are like the easiest equations to solve. Natural log both sides. Thanks for playing. The natural log of a half equals 11k. K equals the natural log of a half divided by 11. And when I do that, I get negative 0.0630. So you don't want to leave it there. I want to know how much does it decay. You got to tell me that as a percent. Move it 2 places to the right. So it decays 6. Okay, so it decays 6.3% per minute. So that's how you answer that one. So that's station 3. All right. Station 4. The half-life of nicotine in the body is 2 hours. What's the continuous decay rate? All right, so here you should be getting good at this. Y equals A e to the KT. Let's start plugging in. They said the half-life is 2 hours. So that means it takes 2 hours for half of it to go away. So I do a half of A equals A E, and it says 2 hours, so it's going to be 2K. Thanks for playing. Half equals E to the 2K. Natural log both sides. Thanks for playing. The natural log of a half equals 2K. K equals the natural log of a half divided by 2. And remember, if it's decaying, this K should be negative, right? If they're asking for that. Oops, just dropped my pen. So make sure that when you put this in your calculator that you just don't do it and not know that ahead of time, because I do know that this is going to be negative. I picked up my pen, negative 0.346574. So how much does this continuous decay rate? It is 34.66% continuous decay rate. All right. Okay, let's try station 5. Okay, station 5. Now these are more like how I want the level I want you to be at, is that you'll be able to use some information to come up with a formula and then answer a question. So this one says if 23% of a radioactive substance decays in 4 hours, what's the half-life? So you don't even worry about the half-life. Let's kind of draw a picture here. So I'm going to draw a picture. So I have this substance, 100% of it. Okay. They told me after 4 hours, 23% went away. So now I have less of it, which is 77% of it left. All right. So if this is a whole A, if you will, in my formula, then this is going to be 0.77 of A left. Because remember, we divide by 100 when you're talking about percentages. So basically, to get you set up here, it says, what is the half-life? So let's kind of set up a little table here. Well, I actually use that information to come up with the formula, And then I'm going to figure out what the half-life is. And a lot of times people try to do the half-life right off the bat. You don't even know what the decay rate is. You just know a half of it. You just know that 23% is gone after 4 hours, excuse me. So I do y equals a e to the kt. Now let's plug in everything we know. 0.77 of a is left, and it took 4 hours. Now we can solve for k. Thanks for playing. 0.77 equals e to the 4k. Natural log both sides. Thanks for playing. The natural log of 0.77 equals 4k. K equals a natural log of 0.77 divided by 4. So k comes out to be negative 0.065341. At least go 4 decimal places, but the more you go, the more accurate you are. So now I know my formula is y equals a e to the negative 0.065341t. So if someone asks me how much does that decay continuously per hour, I can say, 6.5%. Now they want to know the half-life. So now I'm going to find the half-life. So if 4 hours, 23% goes away, if I want to know when 50% goes away, it's going to be more than double that, isn't it? Well, let's try it. A half of A equals a e to the negative 0.065341t, right? Thanks for playing. A half equals e to the negative 0.065341t. Natural log both sides is solve for t. Thanks for playing. The natural log of a half equals negative 0.065341t. Now divide by that. I have t equals a natural log of 1/2 divided by negative 0.065341. And when I do, t comes out to be roughly 10.6 hours. That's the half-life. So again, I want to reiterate, when you get a problem like this, and I'm asking you to come up and answer something, you got to come up with a formula first, or at least find the K so that you can use it to find the half-life. Don't put that in right off the bat, right? So that's station 5. I think this video, I'm going to just do one more, so you're going to have to do station 7 on your own, but I'm going to do station 6, and that's the next one. They said, if the half-life of a substance is 5 hours, what will remain after 9? Well, this confuses people because there's a 5 and a 9. So I said, no, it shouldn't be. Use the first half of this to figure out what your equation is, saying, okay, they gave me enough information to find my K. And I know it's going to be a negative K as well because it's half-life, all right? After that, once I find it, I can figure out what will be remaining after 9 hours. So again, you're going to do your little squiggle chart I do here. You're going to find your formula, and then I'm going to figure out after 9 hours what's left. I don't know. Okay? So let's figure out our formula. All right? So when I do that, I say, ready? We've done a lot of these. Y equals a e to the kt. They said half of it is left after 5 hours. And the 5 I know goes here, so it's e to the 5k. Thanks for playing. A half equals e to the 5k. Natural log both sides. Thanks for playing. The natural log of 1/2 equals 5k. K equals a natural log of 1/2 divided by 5. And I know it's going to be negative, right? So when I do this, I get negative 0.1386, which is a decay rate of 13.86% continuously per hour. All right? So here's my formula. Now, this one's weird because people go, well, how am I supposed to tell you what's left after 9 hours when I don't even know what A is? Well, don't worry about it. You can talk about as a percentage of what's left. So the 9 you're going to put here. So I have y equals a e to the negative 0.1386 times 9. And all you're going to do is just plug that into your calculator just like that. When you do, you're going to get this decimal 0.28 28.7251. So that means when I move my decimal place over, 28.73% remains of no matter what your A is, no matter what you started out with, it doesn't matter. 28.73% will remain of it. So you can answer that. It doesn't have to be in grams or pounds. It can be just as a percentage. All right. So this video is going to end, but there is one more station for you to do, station 7. That's pretty, let's talk about doubling time. So that's a kind of an easy one. Make sure that you show all your work and you can come up with the answer. So that, I hope, gets you started to study for your quiz.